All right, class, in this video, we're just going to work through some mixed practice problems. And I say mixed because there's 10 problems, and I'm not going to necessarily do a lot of teaching, but I'm just going to explore what's the best method for solving that particular system of equations. I'm not going to graph any of these. I'm either going to use substitution or elimination. At the end of the last two problems, there are a couple of word problems. So again, not going to do a ton of teaching and explanation. It's primarily going to be working the problems. As I scroll down, I encourage you to pause the video, work both of the problems on the screen yourself, and then play the video and watch the solution. All right, so with that said, let's get rolling. We're going to look at problem number 1. This is a substitution problem. I already have it in the form of y equals something. So I'm going to take x minus 1 and plug it in for y. 2x minus 3, open parentheses, x minus 1 equals negative 1. There again, y equals x minus 1. So I'm able to substitute it in for y. Let's distribute. So that's going to be 2x minus 3x. Remember, you're distributing that negative 3 throughout. So that would be a plus 3 equals negative 1. When I combine like terms, that's going to give me negative x. I'm going to subtract 3 from both sides. Negative x equals negative 4. So x equals 4. There's the first part of the solution, or the system, I should say. And let's plug it back in. Y equals 4 minus 1. So y is equal to 3. The solution to this equation is 4 and 3. Now always remember that you can check these. Try to cram in a little check problem right there. Let's just use that top equation. 2 times 4 minus 3 times 3. Does that equal negative 1? Well, that is going to be 8 minus 9 equals negative 1. And yes, that is true. 8 minus 9 does in fact equal negative 1. So I feel good about that solution. All right, let's look at problem number 2. Now this is an elimination problem because I see this x variable has opposite coefficients. I have a positive 4 and a negative 4. They're opposite coefficients. So I know that if I just add, those are going to go bye-bye. And 8 plus 2 is 10y equals negative 10. I'm going to divide everything by 10 and get y is equal to negative 1. There's the first part of this system. So let's do 4x plus 8 times negative 1 equals 20. That's going to be 4x minus 8 equals 20. Going to add 8 to both sides and get 4x equals 28. Divide both sides by 4 and get x equals 7. So the solution to this system is 7 and negative 1. Might as well take the time to check it. So here's going to be our check work. Negative 4 times 7 plus 2 times negative 1. And I'm asking myself, does that equal negative 30? Running out of room there. That's going to be a negative 28 minus 2. Does that equal negative 28? And that's actually negative 30, I should say. That's negative 30. This purple is hard to see. And yes, negative 28 minus 2 is negative 30. So I feel good about that solution. All right, let's move on to our next two. And again, I would encourage you to pause the video now and try both of these problems. All right, for this first one, I am going to multiply the top equation by a negative 1. And I'm going to do that because I need opposite coefficients for the y value. I have elected to eliminate the y component. So once I do that, let's write down our two new equations. That's going to be negative 7x minus 2y is equal to negative 24. Again, I distributed a negative 1 throughout the top. I don't have to do anything to the bottom equation. I can just leave it alone. And now I can add. And the negative 2y and the positive 2y are going to cancel. So that leaves me with x equals 6. That one worked out kind of nicely there. Let's move on to our next equation here. So 7x, redo that. I solved for x, not y. So that's going to be 7 times 6 plus 2y is equal to 24. So 7 times 6 is 42. I got to subtract 42 from both sides. All right, so let's think about that. I've got to subtract 42 from both sides. And honestly, the easiest way to see that would probably be to come over here and say 42 minus 24, right? And that's going to give us what? 3, 12, 8, 18, right? But it's going to be a negative 18, so that's going to be y is equal to a negative 9. And there's our solution to this equation, 6 and negative 9. If I were to graph this system, they are going to cross at 6 and negative 9. We'll go ahead and do the check work real quick. And we'll just say 8 times 6 plus 2 times negative 9. And we're asking ourselves, does that equal 30? Well, that's going to be 48 minus 18. Yes, that does in fact equal 30. So I feel good about that solution. All right, let's move on to the second one. Again, pause it and work it. First, all right, so I see this in the form of y equals something. And so that screams substitution. I'm going to sub 5x minus 7 in for y. So here's going to be my first equation that I'm able to solve. Minus 3x, or negative 3x minus 2 times, so it's open parentheses, 5x minus 7 equals negative 12. Let's distribute. Negative 3x minus 10x plus 14 equals negative 12. So I'm going to subtract 14 from both sides. I'm going to combine like terms, which is negative 13x. And then I'm going to add 14, about to lose track of what I'm doing here. Negative 13x equals negative 26. Divide both sides by negative 13. And you get x equals 2. So let's plug it back in. Let's just say y is equal to 5 times 2 minus 7. So that's going to be 10 minus 7, or 3. So the solution to this equation should be 2 and 3. Let's check it to make sure. Try to stick our check problem way up here. And let's use the other equation, negative 3 times 2 minus 2 times 3, and does that equal negative 12? So that's negative 6 minus 6. Yes, that does in fact equal negative 12. So I feel good about the solution to 3. All right, let's use problems 5 and 6. Again, please pause the video and try this on your own first. All right, let's see. When I look at number 5, I'm going to have to multiply this equation by something. Nothing's going to cancel. And why don't we cancel the y? Let's eliminate the y. To do that, I'm going to need to multiply by a negative 3. And so my new equation here would be 3x, minus 3y is equal to negative 9. Let's write our top equation under this one. So this is that first equation. I have opposite coefficients in front of my y, so I know I can add these, change colors again. Those are going to cancel. Oh, but wait, look what happens. I have opposite coefficients in front of the x, so technically this would be 0x plus 0y is equal to negative 5. That is what we call no solution. That does not work. Why? Because 0 does not equal negative 5. This system is not going to cross anywhere. So now another way to see this would be like this. We could say that this is going to be 3y is equal to 3x plus 4, okay? Or y is equal to x plus 4/3. Now let's use this one. This would be y is equal to x plus 3, okay? Same slope, different y-intercept. These are parallel lines. They have different y-intercepts but the same slope. So we know that they're going to graph something like this, right? They're never going to cross, and that's why we call it no solution. All right, so let's move on to our second problem. Again, nothing immediately cancels. So that means I'm going to have to multiply both equations, both top and bottom, by something why don't we just choose the x? Why don't we eliminate the x? And so that means I'm going to need to multiply this equation by 7 and this equation by a -2. Now I'm choosing a negative there because, again, I have to have opposite coefficients in front of the x. They're both negative, so one of these coefficients has to be multiplied by a negative. Yes, I could do -7 and +2. I could absolutely do that to solve this equation. I just elected to do it that way. All right, so let's rewrite our first equation. That's going to be -14x plus 42y is equal to 42. That's going to be a 14x, I'm working on the bottom equation, minus 16y is equal to a +10. Now, I have opposite coefficients in front of my x, so they're going to go bye-bye. So, what's 42 minus 16? 42 and 10 is 52. I know I've got a y. All right, so 42 down to 20, that's going to be 22. Another 4 is going to be 26. I'm going to use the sign of the larger number, which is positive. And here I divide both sides by 26, and I get y is equal to 2. Okay, so let's plug it into one of these equations. How about the top one? -2x plus 6 times 2 equals 6. That's going to be -2x plus 12 equals 6. I'm going to subtract 12 from both sides and get -2x equals -6, or x is equal to 3. So the solution to this one would be 3 and 2. Let's go ahead and check it. If I can squeeze it in maybe right over here. Let's pick the other equation. -7 times 3 plus 8 times 2. And does that equal -5? So that's going to be -21 plus 16. Yes, that does equal -5. So I feel good about my solution. All right, let's scroll way down here and get past this white bar. And there's 7 and 8. You can see we're starting to get into our word problems. Pause the video and give this a shot. All right, so this is a substitution problem. We see both of them are in the form of y equals. So let's just take -5/2 x minus 1 and place it for the y in the first equation. So my new equation is -5/2 x minus 1 equals 1/2 x plus 5. Now don't let the fractions monkey with you here. The good news is I've given you some, they have the same denominator. So that makes your life a little bit easier. Why don't we do this? Let's subtract 1/2 x from this side and this side. That means we're going to have to add 1 to both sides. All right, now this goes back a few lessons. I'm not going to review that. So these cancel, those cancel, and I'm going to write it out longhand so you can see it. -5/2 x minus 1/2 x, and that's going to be 5 plus 1. So that's 6 on the right-hand side. Now we're subtracting here, so we know we're going to have an x. We're going to have a fraction over 2. We're going to keep the denominator the same. Negative, so then what is -5 minus 1? Well, that's a -6. So we should have -3x equals 6, or x equals -2. All right, so let's go ahead and plug this into one of these equations. Y is equal to, let's do 1/2 of -2. This one would be easier, plus 5. So that's y is equal to -1 plus 5, or y is equal to 4. So the solution to this one is -2 and 4. -2 and 4. Let's go ahead and check it. And let's see, let's plug in 4 equals, let's use the other equation, -5/2 times -2 minus 1. And do those equal? Well, the 2 here and the -2 become -1. -1 times -5 is a 5. All right, so 5 minus 1. Yep, that works. Let's walk back through that again. Here, the -2 and the 2 become -1. So that if I rewrite this problem, it would be -5 times -1 minus 1. Negative times a negative is a positive, so that's 5 minus 1. So this does, in fact, work. All right, let's look at a word problem. Now remember, when you work through these, you've got to decide what variables to use and I am about to run out of time on this video. I'll have